Hey guys, Majoo up here, and welcome to the 12th video in our 2D Java game series. Today, we are going to be doing alpha rendering. So last time we set it so that if our alpha value is equal to 0, then we are going to not render it at all. But what if it's slightly faded, right? We got our image over here, right? We're going to need two images here to test this on. So I'm going to just start off this episode by creating the images. So let's have a pattern, and I'm going to actually make this image the size. We're going to make it bigger, basically. Actually, we can just have two of these images. That'll be fine. All right, we'll save that. Yeah, we'll just export that as our test image. All right, so now we have. I didn't refresh, but it still works anyways. So we got our image here. Now we need to draw transparency. So here is the problem with transparency that we have to overcome in order to draw it in the first place. When you render a transparent, like when we're rendering our pixels, if you render one pixel, right, you render your image, and then the next image you render will render on top of it, right? So if we render a transparent image, right, it will go first. If we render it first, it'll go on top, but then an opaque image can go on top of that. And that's not necessarily what we want. So we want to have a Z buffer, right? We want to give our image some depth. If we have alpha in our image, then we're going to bring it to the top. We're just going to bring it all the way up. So what we're going to do here is we're going to have a private int array ZB, as in Z buffer, right? It's a Z buffer is what it's called. We're going to technically have a Z axis now in our image. So our ZB is going to be equal to new int array, and we're going to have p.length as the length of it. And when we clear it, we need to clear our depth buffer. So what we're going to do is I'm going to have 0 be at the bottom of the image, and the higher the number, the higher it is on top. So when we clear it, I want to say zb dot zbi is equal to 0. Okay, that's going to be our default state. Okay. So now we have these options, right? So we're going to test this. Now I want to do a test if our image, right, if our value here, I'm going to store our value int alpha is equal to this, because we're going to need to know that for more calculations. So if our alpha is equal to 0, just return, right? But if our alpha does not equal, now this goes all the way up to 255. So that means if our alpha is not maxed, we have a transparent pixel. And I'm going to... we could bring it to the top. The problem, I mean, sometimes you want things on top, some things you don't. We may not bring it up to the top here. We may have to have, when you're coding the game, you have to say, change the depth buffer up to the top in order for it to render at the top. Otherwise, it can get rendered over top of. That probably will be better. Okay, so we're just gonna leave it like that. We're not gonna change the Z buffer that we are at. Okay, but we need to know what ZB we're at. So I'm gonna have a private int Z depth. I'm actually gonna write this one out. I'm going to set it equal to 0. So by default, we'll be rendering on the depth of 0. And we're going to change that with getters and setters. Right? So we're going to set that as the last member. Okay? So when we come in here, we're going to do another test as well. Or our ZB I is greater than our Z depth. So if there is not I, we need to, this has to be after the fact, because we need to do this line of code. We got to make sure that it's in bounds, because this code checks to see if it's in bounds. So if ZB x plus y times pw is greater than our z depth return. Simple as that. So if there's already an image there, we'll return. Now we're going to actually render the image because we're on top of the image on the pixels that are already there, and we want to render image. So if alpha is equal to 255, I just want to render the image, right? Render the value onto the image, but I need an else because we got to do something if that is not the case. Now normally I would make a separate class for all these all this code, but it's quicker if it's just right in there. It doesn't have to do a method call because we're doing thousands of pixels per frame. You know, this could slow us down if we're doing a bunch of method calls. So we have to change it. Now we have to figure out what our new int value is, so our new color, right? We gotta know what this is. I'm just gonna say this, and our color is gonna come out there, right? So how do we blend alpha channels? So you have like your red, your green, your blue for the pixel that's already there, right? So let's just say this is we're gonna make it floating point numbers. We don't really need floating point numbers. Yeah, we'll have it. No, we won't need. So like we have 255, 75, 65, right? And our new image though has 275. Not 275. We can't go that high. Like 125, 50, 60. Right? Now, if our new image right here is solid alpha, these values get replaced, right? But if the alpha is between 0 and 255, that means the previous image, right, the previous pixel there, moves towards this number depending on the ratio. So like if it's 1, this number moves all the way here. So it changes from 25 to 125. But if it's a half, it'll move halfway from here to here. Does that make sense? And that's how you do alpha blending. So we got to do that in our little code right here. So I'm going to say int new red is equal to, let's get our base red, which is our PW. Now we're going to be doing a lot of calls to this. So I'm going to say int pixel color is equal to P X plus Y times PW, just so we don't keep calling, accessing that array. We'll just access it. We'll store it. We'll access it once and store it. So pixel color, right? And now we need to know the red. In order to get the red, we shift it over 24 to get the alpha. We move it over 16 to get the red. So I'm going to shift it over 16, and I'm going to AND it with 255, aka FF in hexadecimal. So we have the red value of the pixel that's there. Now I'm going to take this color and I'm going to add onto it, right, the same color, okay, and then we'll put this in parentheses, minus the color of our value. So I'm going to paste that again, but I'm going to change this from pix color to value. So we're gonna find the difference between our new color and our old color, and we're gonna add it here. But I'm going to take this difference and multiply it by our alpha, right? And I'm going to put that all in parentheses and say multiply by alpha divided by 255, because I want this to be a float. Okay, and then I'm going to cast all of this that we're adding to an int. And that should blend our red. Now we got to do this 2 more times for our other colors. So we got int red, int green, and our new blue. Okay. We're actually going to get rid of this color part here, because I'm just going to directly set it here in a second. So we don't shift over by 16 for green, we shift over by 8, and we don't shift over at all for our blue. Okay, and then let's change that over here as well. Same thing here, 8, nothing here. And that should work, right? Yes, I think I changed everything. So now we got to set our new color. And in order to do that, we got to combine these 3 integers into one new integer. And the way you do that is we got to set the 4 bytes in our code. We got to convert these to bytes and set them. So we're going to set the first byte, and the first byte in a color integer is the alpha value, which is 25, because we want this to be solid. So we're going to say 25. All right, and then I'm going to do an OR, which is going to all combine them together. I need to shift this 25 over by 24. Right, we're going to go to the left this time instead of the right. So we shift over that. Now our new red, I'm going to shift that over to the left by 16, and I'm going to OR it with the new green, with it shifted over to the 8 by 8, and then our new blue at the end. Now this is going to take our 4 integers and make one new integer out of it and store it in our pixel. And that should give us alpha blending. Right, you see why I changed this to one image. So if we run this, we should get the same thing. We do. We need a version of this image that is transparent. So I'm going to take our opacity, kick it down a bit. I'm going to add an alpha channel. I'm going to delete the white that's here. Right, zoom in. And then I'm going to dump in our transparent wood. And let's go back. Go to our image, our engine here. We got our test. I'm going to call this test 2. Export. Now let's go back to our image here. We're going to private image 2, image 2 equals new image test2.png, and I'm going to move test2 with my mouse, and I'm going to draw our image here of image 1, and I'm going to draw it at 10, 10. Right? So here we go. Cross your fingers I did this correctly the first time around. Oh, I can already see some problems. But okay, so we have our black. It's not rendering. And when we pull it over our image here, we get an interesting result. So I messed up somewhere. Let's find out. It might be because I got rid of some parentheses here, because the parentheses can screw you over. Right? Let me check some real quick. Make sure I got, yeah, get red. Okay, what's our problem here? We have a problem, and I need to fix. Let's have those parentheses back there for a blue. Does that change anything? Because I don't think I had. No, that did change something actually. That is so weird. An interesting result we're getting, nonetheless. So we have our base color, and we're adding on the difference. I think we need to subtract the difference, not add it on, because I think the way we're getting it here is it's giving us the inverse. That's interesting. We're getting somewhere here. Alrighty, problem solved. It was parentheses, and not that I have too many, but I don't have enough, because the PEMDAS for bit shift operators is a little weird, as in the order of operations. This, it doesn't do this and then this and like together. It's been doing, it's subtracting, it's taking this and subtracting it from 25 and then ending it with this. So what the fix is adding more parentheses. So we're going to put parentheses around the beginning here, just like that. And for the same thing for red and green. Blue is fine. Blue's working perfectly fine. It's red and green that's not. And then inside of our integer here, where our value is, we got to put parentheses around that as well to make sure that it does it in the correct order. Because all this has to happen in the proper order. So now, given that line of code, get a good look at it. All right? Pause the video if you have to. If we run it, I also changed the image for testing. Hey, look, our image is half bright, and when we put it over there, it overlays with our old image. That works perfectly fine. Now we have alpha blending. You can see this hurts our frame rate a bit. It's not bad. 3000 FPS isn't bad. All right, so we have alpha blending now in our engine. Now with our Z buffer, we added it and we didn't even use it. Well, the thing is, if I was to take my image, right, my non-transparent image and put it below the transparent image, right, I have my image over here and like, okay, I want to overlay it. Nope, it's behind it. It's behind our image. So if you want to make sure that your image is rendered above it, regardless of what level it's at, what you need to do is you need to do r.set z depth and to integer.max value. So it goes to the max value, and then whenever you render something else, set the depth to 0. Right? So if you want to absolutely make sure it's rendered above it, you can do that. We're not getting above it. So what's the problem here? It's rendering our image. Oh yeah. Well, even if we do change it with the Z depth, it doesn't change the fact that it's black where we're rendering it. We have to render our image last. So we still have a problem that I completely neglected to fix. The Z depth we needed. It's very useful, but we still have a problem with our alpha rendering. Alright, and let's try and fix that this episode. So, how can we fix our alpha rendering? That is a problem. Well, there is 2 ways of doing that I can think of. And one way I know will work. The second way, it'll be interesting. The one way is what you do in OpenGL, and that is you organize your renders. So, when you render in OpenGL, you store what you're going to render, and you render the farthest things away, and then you render it as it gets closer, right? So you want to start from the back and come to the front. So if you render from the front and go to the back, you mess up your transparencies. We can do that and organize it, and have it render anything with alpha, an image with alpha last, right? We still do the Z depth, keep track of that so it renders in the right Z depth layer, but it renders last. Or we can try something weird, but it wouldn't maintain the Z depth. We're going to have to organize our image. So how can we do that? When we draw our image, we're going to have to set a variable in our image, and I'm going to call this private boolean alpha, right? And this is going to be set to false. Now, if our alpha boolean here is set to true, we are going to basically, when we load it in, right, our test2 has alpha, so I'm going to say f2.set alpha true. It has alpha. And that's going to be important because we need to know what images have and don't have alpha. Otherwise, we have to check an image every time we want to like render it, which would be silly. So you have to say, hey, this has alpha, render it last. Now, what we're going to do is I'm going to make a new class. I'm going to call it image request. And this is going to have public image request. We're going to say it's going to take in an image. It's going to have an int z depth, We need to tell what z depth we're rendering at. And then a location. We need the actual location. So int off x, int off y. So what I'm going to do is make a private image, private z depth, private int z depth, private int off x, off y, and make and initialize everything. This dot image equals image. This dot z depth equals z depth. This dot off x equals off x. This dot off y is equal to off y. All right, and I'm actually going to. We might as well make these public because this is going to be handled directly by the image, and it's not actually going the engine. And the person who's programming with the engine, if someone else was to be programming with it, they're not going to have access to this. So we have our image request class. We're going to go to renderer. This is going to be quite a long video, but you know, that's how it goes sometimes. And I'm going to pair these together with all these. Let's I'm going to move some things around. And say up here we'll have a private array list, and we'll call it image request, which is going to be image request. Call it like creative names is equal to new array list image request. Boom. All right. So when we draw our image, right, we're gonna have a draw image code. So like we're just gonna act like normal. Everything's normal, right? When we call our draw image, if our image that is alpha, right, we're going to say image request dot add new image request. We'll add our image, our current z depth, whatever that's set to, our offset x and our offset y, and then we'll return. Okay, so if we start to draw something that has alpha, we're going to stop. We're going to add it to our image request, and then we're going to get out of there because we need to have, and then we're going to render it the last. So we're going to have a public void. I'm going to call it process. I don't know any good way to do that, but this is actually going to be a class method we're going to add more to than just alpha rendering. So now we're going to render our alpha. So if, so we're going to just do a for loop of, we'll do a special for loop. So image request IR image request, because we're not going to be modifying our array. Then I'm going to say IR, and so I'm going to say draw image ir.get ir.image ir.x ir.y, and also I need to say set z depth. It's actually a lowercase z depth ir.z depth. Simple as that. And then once we're done, I'm going to say image request dot clear, which will get rid of all of our requests. So now we have our images organized. We go back here, and same thing, doesn't matter. It should work off the bat, actually. So we don't have an image here. Oh yeah, we didn't call process. Process has to be called in order for it to work. So we'll go back to our game container. And what I'm going to do here is after we render our game, and before we render our text, because I want the text to be on top of everything, I'm going to call renderer.process. All right. Ooh, we got an error. Concurrent modification exception. Is that really a modification? Okay, so we got a problem with the, it has a problem with the thread. So I'm going to actually change this to a proper for loop, which is basically why it's complaining. is less than image request dot size I plus plus. That specialty for loop does have problems, so we're just going to do that. And I'm going to say image request IR is equal to image request get IR. I mean just I. So we can just leave that code the same. And then we run it. This one will crash. Ooh, we got a problem. Oh boy, we have an infinite loop, it appears. Is this our infinite loop right here? Is this what's happening? What's our problem here? Hey, oh wait. Because we're saying render with alpha, it doesn't work. So we have to change this code actually right here. So we have to say IR, because it keeps, we're drawing our image and then it adds it back here, and then we try to draw our image and then it just adds it back in. So yeah, we have an infinite loop. So I'm gonna just say IR.set that get IR.image dot set alpha false. That should not modify our original image. Hopefully it's a clone. Nope, it did modify it. Oh, darn. How can we get past that without getting rid of our alpha? I'm gonna do a. This might come in handy later. Sometimes do. So I'm gonna have a private boolean called processing. I'm gonna set it equal to false. So our processing, I'm gonna say processing is equal to true. And then at the end here, I'm going to say processing is equal to false. So basically, I'm going to have a specialty code here in my draw image that says only do this if processing, if not processing. If we are processing, we don't care. That should work. There we go. And it overlays it, even though we're drawing the box image last, and the transparent image first, we get our alpha overlay. And that is why alpha is very annoying. Okay? So there we go. This is a long video, a very long video. But I hopefully you learned something. So yeah. That should do it. Alright guys, comment, rate, subscribe, and thanks for watching.